Hi, in this video we're going to look at proof by deduction, and this is a method that uses logical mathematical steps, often with algebra, to show that particular statements are true. And so let's go through a couple of typical examples. In the first example, we've got to show that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. And in the second, we've got to prove that for any 3 consecutive numbers, the difference between the squares of the first and the last numbers is equal to the middle number multiplied by 4. So let's have a look at the first question. Notice the words 2 consecutive odd numbers. The word consecutive means following after another, and so we need an odd number followed by the next odd number. Now, we can't just think of 2 random odd numbers, such as 3 and 5, because this proof needs to be true for all consecutive odd numbers. And so this is why we have to use algebra. Because with algebra, you can represent any odd number as 2n plus 1, where the n is an integer. And this is because the 2n in 2n plus 1 will always be even, because any number multiplied by 2 is going to be even. And so you should see that if you add 1 to an even number, you'll then get an odd number. And actually, we could have also chosen 2n minus 1 to represent an odd number for the same reason. Okay, so if 2n plus 1 is an odd number, the next, or consecutive odd number, must be 2n plus 3, because if you add 2 to an odd number, you get the next odd number. Now the question says the sum of the squares of 2 consecutive odd numbers. So we need to square these 2 expressions and then add them together. So 2n plus 1 squared gives 4n squared plus 4n plus 1. And 2n plus 3 squared gives 4n squared plus 12n plus 9. And if we then add these 2 together, we get 8n squared plus 16n plus 10. Okay, so we now have to show that this quadratic expression is 2 more than a multiple of 8. And to show that something is a multiple of 8, all we need to do is take out 8 as a factor. And to then show that something is 2 more than a multiple of 8, we need to add an additional 2. But only 2 of the terms, the 8n squared and the 16n, have a factor of 8. And we don't yet have a remainder of 2 either. So the way to get around this is to split the 10 into 8 plus 2, because you'd then have 3 terms with a factor of 8, and you'd be left with a remainder of 2. So we now get 8n squared plus 16n plus 8 plus 2. And we can then take out 8 as a factor to give 8 multiplied by n squared plus 2n plus 1 plus the additional 2. So we've now proved that the original statement was true, because anything multiplied by 8 is going to be a multiple of 8. And if we then add 2, this is 2 more than a multiple of 8. Okay, so now let's have a look at the second example. So the question says 3 consecutive numbers, but doesn't say whether they're even or odd. So using algebra again, we can just represent any number as n, and then the next one would be n plus 1, and the next one after that, n plus 2. And we now have to square the first and the last numbers. So n squared gives n squared, and n plus 2 squared gives n squared plus 4n plus 4. We can now work out the difference by subtracting one from the other. And so we get n squared plus 4n plus 4 minus n squared, which gives 4n plus 4, because the n squared terms cancel. And we can now factorize this to give 4 multiplied by n plus 1. And as you can see, this is 4 times as big as the middle term, which was n plus 1. So this proves the original statement. Okay, so that's how you answer typical proof by deduction questions using algebra. If you found this video useful, please like it and subscribe to my channel, where you'll find more A-level maths videos. Thanks for watching.